Okay, here's number 18. To determine the value of c so that f of x is continuous on the entire real number line. Okay, and this is my f of x equals x minus 2 when x is less than or equal to 5, and cx minus 3 when x is greater than 5. And again, these are lines, so these lines are going to be continuous for all values on their domain. So we're just interested in what happens at the juncture point. So all we have to do is make sure that they have the same vertical position. It means they connect at x equals 5, and then the whole function will be continuous. That's the only possibility where we'll have a break. So all I did was, I did the work over here so it's a little bit easier to see. So we just said x minus 2 equal to cx minus 3 at x equals 5. So every time I see an x, I put a 5 in. And I get 5 minus 2 is 3, and then 5 times c minus 3. Add 3 to both sides, divide by 5. So when c is 6/5, then these two functions will have the same vertical position. All right. And they just ask you to find the value of c, so that's just 6 over 5. That's all you had to do. And you could check that in here if you wanted to. We did the check on some of the homework problems. But I don't think that's necessary. We're okay here. All right, and then if we take a look at number 19, we want to find a power function and behavior model for this function. So again, I did this over here. I just kind of rewrote this. And what I did was I looked at the top of this. I kind of rewrote it in descending powers. So I wrote the negative 2x to the 5th first, plus 3x to the 3rd, plus 2. And then we can see that as x approaches infinity, that's what we're looking for, an end behavior model. The dominant term of the numerator will be this, negative 2x fifth. The dominant term of the denominator will be 3x squared. And we can simplify these. X squared into x to the 5th is x to the 3rd. And there's your end behavior model. Negative 2/3 x to the 3rd. So power function could be y or f of x. We could call it y. Equals negative 2/3 x to the 3rd. Or you could call that f of x or g of x if you want. Okay? All right. Number 20. Pardon me. Number 20. Give the formula for the extended function that is continuous at the indicated point. So at x equals negative 1, again, if we put negative 1 in here, we'll get 1 plus 7 is 8, minus 8, we'll get 0 over 0. So again, we know that there is a removable discontinuity. And get rid of it by factoring. So we factor the top, so I did the work over here. Just factor that. Cancel out the x plus 1s. And there's your continuous function. These will graph to be the same, except this will have a hole when x is equal to 1, and this will have no hole. Will be filled in. Okay. And the last one, number 21. So our function would be f of x, or I could call it g of x, equals x minus 8. That would be the extended function. So that's not too hard. And then number 21, what should be assigned to k? What value should be assigned to k to make f of x a continuous function? So this is the same idea, except I'm using a piecewise function. So I'm wondering what k should be. So again, if we substitute this at x equals 3, we know we're going to get 9 plus 21 is 30 minus 30 is 0 over 0. So we factor it. You know we can. Find the removable discontinuity by various methods. This way we can just factor it. X minus 3's cancel, so we have x minus 7. So my one extended function would be y equals x minus 7. So all I have to do is put 3 in to find out what the value, what the vertical position will be. All right, so if I put 3 into this, 3 minus 7 is negative 4. So actually the hole here, the discontinuity, the removable discontinuity, occurs at the point 3 and negative 4. So this is the problem. So what I can do is I can look at this And I can say, well, this is equal to the function for all the values except at x equals 3. So I'll say it's not going to be equal there. And at x equals 3, it's going to be equal to k. And what's k going to be? K will be negative 4. And that's going to fill in that point 3, negative 4. So k will equal negative 4. So if I put that value in for k, at x equals 3, that's the point 3, negative 4. That's going to fill in the hole there. Otherwise, it's okay in all the other points. Okay, so I hope those make sense.